So one of the main types of exponential growth is dealing with money and really finance. So what we're going to look at is compound interest, which is the most common type of interest when you're investing or you're paying loans and things like that. So pretty much everything is earned in one of these following compounding periods. And what that means is that the interest is applied that many times per year. So annually, it's only applied once. Semi-annually, it's applied twice. Quarterly, 4 times. Monthly, 12. Weekly, 52. And daily, 365 days. Now, we're not going to deal with leap years. Just makes things too difficult. So we'll just stick with 365. We always use this formula. Now, this part right here is actually our interest that's being earned. 1 deals with 100%. And then NT is our number of times we're collecting interest. So when we're looking at this formula, A is always our final amount. Okay, it's the final amount of money at the end that we've paid, or the final amount of money that we're going to get. P is always your principal. Okay, it's the starting amount. R is the rate. So that's the rate as a decimal. And it's per year. Okay, we address the compounds after. Per year or per annum, you'll often see in the questions. Okay, N is the compounding period. So how many compounds per year? So like yearly, monthly, weekly, yada, yada, yada. And then T is the number of years. All right. So that should be a common formula that you've seen before. Okay, now looking at this, Bob invests $1,000 at 6% compounded quarterly. How much is it worth after 6 years? So what we're going to do is we're going to run through that whole formula. Sometimes it's helpful if you do something like this. We know A is a question mark. P is our principal. That's 1,000. Okay, R is 6%, but we want to make that into 0.06. T is going to be 6 years. Okay, so we've got everything there, and then we're going to just fill in that formula. I'm going to write it up here. So we've got our formula. So A is equal to, we've got 1,000. Now I'm putting 1,000 in brackets because I can't include that in my exponent, and that's probably the most common mistake. So I'm going to have 1 plus, and then 0.06 over, it's compounded quarterly, so our N, I guess, is 4, over 4. And then we've got times 6 times 4. Okay, now when I do this, I start inside and I really apply bed mass. So I'm going to do 0.06 divided by 4. I get 0.015. Then I'm going to add 1. That's my brackets. Now I've got inside the brackets, and I'll just write this in for you, but I just leave this in my calculator, 1.015. Now my exponent is going to be 24, but if I didn't know that, I would just use my brackets in my exponent. 4 times 6 is 24. So we've got our exponent, which is now going to give me 1.42 or 429. And then I'm going to times that by 1,000. And I'm going to get roughly, I mean, you need to round money to 2 decimals. So when we get it, therefore we get $1,429.50. Okay, how long would it take his money to double? Now we've done questions like this before. But if we're doubling, all that's going to be different is we've got A equals 2,000, P equals 1,000, R is still 0.06, N is still 4, but in this case we don't know what T is. Now this one's a little bit harder because T is going to be in our exponent. So we're going to have 2,000 equals 1,000. We've got Now inside the bracket, it's not going to change, so it's going to be 1.05. That's just me cheating a little bit because we've already done the 0.06 divided by 4. And then we get to the t times 4. So we're going to get 2 equals all of that. So because we've divided the 1,000 over as the first step, I'm going to just write it as 4t now. Now here's where we can use our logs to get our answer. So we're going to say 4t equals the log of 2 over the log of 1.015. And then we're going to get an answer to that. And we're just going to divide it by 4 because we've got the 4 on the other side there that we have to divide over. And we should get t is equal to 11.6. So we would say approximately 12 years. Now you could say 11.6 years if you wanted to. I'm going to just put 12. Okay. How long would it take his money to triple? Well, we're going to do the exact same steps. Just A is going to be 3,000 in this case. And I'm not going to write everything else out, but we'd get 3,000 equals 1,000. And then 1.05, or 015, excuse me, to the 4t. We get 3 equals all of that. And then we're going to do the same steps in our calculator. 4t equals the log of 3 over the log of 1.015. Now I'm going to run out of space here, so I'm just going to move over here and say that t is equal to, we're going to do that same stuff, the log of 3 divided by the log of 1.015. And then this time we're dividing that by 4, and we should get around 18 years. Whoops. So 18 point, we'll say 4 years, therefore approximately 19 years. Okay, I'm just rounding up because it takes at least that amount of time. So if we were rounding to the nearest year, it would be after 19 years. Okay, final question. We've got Tom's investing some money. So we know that t is 4 years. We've got compounded monthly, so our n value is 12. We're investing 10 grand, so that's our p value. We want to know it's going to be worth 15,000. And we need to know what the r value is going to be equal to. So this one's a little bit harder because our variable's inside our bracket. But really, if we think about our formula, we plug everything in here. There's our r value that we need to find. So we're going to get 15,000 equals 10,000. And then we've got 1 plus, we don't know what r is. Now remember, when we find r, it's actually the percent as a decimal. So we're going to have to do a little bit of work there. We've got a 12, and then what do we have? 4 times 12 and the exponent. Okay, so we get 15,000 divided by 10,000 is our first step. And a lot of people can do that in their head, obviously. We're just going to get 1.5 is equal to. Now we've got 1 plus still r over 12. Now this is going to be 48. Now to get rid of that 48, I need to do 1 over 48 as an exponent, or take the 48th root. So however you want to do it, I again always use a power. So I'm going to be doing the power of 1 over 48. And I'm taking the that power to the 1.5 because I need to go to the other side. So I'm going to get, I'll write it like this, 1.5 to the 1 over 48 is equal to 1 plus r over 12. Now that's going to be approximately 1.008. And I'm just writing that decimal because I want you to see it. There's a bunch of stuff after that, and I'm leaving all that in my calculator. And that's going to be 1 plus r over 12. So I'm going to subtract the 1 over and get 0.008. And then I multiply that number by 12. So I get 0, whoopsie. Let's fix that. I get 0.008. And there's 484 we'll write in this time. Equals r over 12. And then we just times by 12. And we get r equals 0.10, and I'm going to write 2. So that's approximately, therefore, approximately. How to make it back into a percent, we just multiply by 100. So this times 100% gives us about 10%. And there you go.